On this Earth Day episode, we're talking about a promising solution to combat harmful carbon emissions. SWRI scientists and engineers are exploring the possibilities of hydrogen gas. Their research is getting us closer to a carbon neutral future, a cleaner energy source. Next, on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. Transcripts and photos for this episode and all episodes are available at podcast.swri.org. Hello and welcome to Technology Today. I'm Lisa Pena. At the end of every episode, I tell you where you can find the Technology Today magazine, an SWRI publication. It's available at technologytoday.swri.org. This month, our spring 2022 issue is out featuring the article Hydrogen and a Carbon Neutral Future. The author is SWRI mechanical engineer Angel Wileman, who is leading the Institute's Hydrogen Collaboration initiative. She and several other engineers write about their research to transition away from petroleum-based fuels with cleaner hydrogen. Angel joins us for our Earth Day episode to talk about the possibilities of hydrogen gas and what it could mean for the environment. Thanks for being here, Angel.
Thank you, Lisa. It's a pleasure.
So I've read the article, and hydrogen technology sounds really promising, and it feels like it could be the way forward toward becoming carbon neutral. But before we dive into the potential solution, let's start with the problem. The issue is carbon dioxide emissions negatively impacting the environment. Describe this problem for us. What does our current situation look like?
Thanks, Lisa. Yes, carbon dioxide emissions in our atmosphere are a problem because they are causing the Earth to warm up. And we've all heard of greenhouse gases and climate change, global warming. So what's happening is that the CO2 in the atmosphere is trapping the sun's energy that comes into the Earth, and it's not allowing it to get out. So it's basically just warming up slowly over time. This causes a lot of problems for the Earth. Actually, the ocean is able to absorb a lot of this CO2, and it's been doing that for a while. But I don't know if you knew this, but CO2 in water actually makes acid. So that's bad for our marine life. And the warm temperatures also are melting the polar ice caps and changing even some of the currents in our ocean. So there's a lot of things happening. And I don't mean to sound so bleak and dire, but it is something that we need to look into. We routinely release CO2 into the atmosphere with our energy production and our chemical plants, just driving our cars. We breathe out CO2. I mean, just living, we create carbon dioxide. So if you were to stop a person from emitting carbon dioxide, they would die. So I don't think we should do that because they need to breathe in oxygen and emit carbon dioxide. But there are ways that we can combat this problem.
Yeah, so, this is the reality, and we need a fix fast. There are many reasons that so much carbon is being generated. The population is part of the problem. Can you talk about that a little bit more? The sheer number of people on Earth.
Yes, the sheer number of people on Earth. So this is actually kind of a great problem to have. Over the last 100 years, we've made amazing advancements in medical procedures and just our quality of life. More people have clean drinking water now, even though we are, we're doing other things to our water supply. But that's another podcast. But people are living longer and they're living better. And all of those people on Earth are using energy and they're creating CO2 and other emissions that are leading to climate change. And I think this is a kind of a double-edged sword. We don't want Marvel's Thanos to be around. For those of you who are not aware, he, in that story, he snapped his fingers and half of the population of everyone disappeared. So that's not the solution we need. We need something that will allow us to stay healthy and live with our quality of life and do it in a cleaner way.
So we need to find a new way of doing things. The goal is to become carbon neutral and limit those harmful emissions. SWRI scientists and engineers believe hydrogen will help us get there. So, why hydrogen? How is it better for the environment?
So one of the best things about hydrogen is the, chemical formula is H2. So there's just two H's, there's no C's. If you have any C's, that's carbon, and when you have carbon, it is possible to have CO2. So when you use hydrogen, there's no carbon involved. So you don't have to capture carbon or, mitigate that unless you're making hydrogen from fossil fuels, which we'll talk about. But it inherently is carbon free, and that's really good. But the other thing about hydrogen is it has a lot of qualities for energy storage. Princeton came out with a study, and they looked at all of the energy that is used worldwide right now, and not just energy for electricity, but what is the feedstock for energy used everywhere. And right now, renewables are a pretty small part of that. It's around 10%. In order for us to become carbon neutral by 2050, that number is going to have to grow significantly. In fact, oil and gas are still probably going to play a role in some of these models they put together, but their use would be reduced by 50 to 75%. And renewables are going to take up that slack. So if we're using renewables to make energy, that is great because we're using, wind, solar. So we're using these other sources of power, which are already available on our Earth, and we don't have to burn fossil fuels to get them. But the wind only blows sometimes, and the sun only the sun only shines sometimes, and it varies day to day. It also varies season to season. So to get the nice stable energy supply that we're used to and that we can get with natural gas, we're going to need to find a way to store the power that is made by those renewable sources and use it later, like months later. And when you look at energy storage, there's only a couple of options that'll really get you into the large range and long duration storage that we're talking about here. I mean, we talk about batteries. So batteries are really useful for storing energy for short periods of time. And they can actually be efficient up to storing for hours and days. But, the feedstock, the things to make batteries are also, um, there's some rare chemicals that are involved in that. And supply of those chemicals is a whole nother issue. Um, but when you look into kind of the gigawatt scale energy storage on a seasonal basis, up into months, you get into only thermochemical storage is going to get you there. And thermochemical storage comes down to hydrogen or hydrogen carrying chemicals like ammonia. So we can use renewables to make the energy, use hydrogen to store it, and use it when we need it. So that's why hydrogen is so great.
So, to back up here a bit, carbon neutral, that may be a new term for some of our listeners. Will you define that for us?
Sure. Carbon neutral means that when you complete a process, you're not emitting any more carbon into the atmosphere than was already there. So, for instance, if you get energy from biomass, and let's say, you have a tree, it turns into waste, it turns into biomass waste, and you somehow convert that into a fuel. When you burn that fuel, you're releasing carbon back into the atmosphere, but that carbon was already kind of there in the life cycle from that tree. The carbon that we're releasing with fossil fuels has been locked up underground for millions of years. So that carbon was not part of our normal environment, and it wasn't really here before we burned it. So that is where you get into carbon neutral. You can actually release carbon with a process by burning something, but as long as it didn't come from a fossil fuel, you're pretty good for it came from like our environment.
So, the goal is to be carbon neutral by 2050. Hydrogen could help get us there. And you explained to us, hydrogen, H2, has no carbon. But why is hydrogen unique? How is it unique? What properties does it hold that make it ideal for the task of storing renewables?
Hydrogen is available everywhere in nature. I mean, most of the ways that we get hydrogen come from breaking apart water. So we break apart water in a process called electrolysis, which releases hydrogen and oxygen. And I know we have another podcast on water, and I've listened to that one recently about it as a precious resource. But the water is more available than some of the materials that go into making batteries. So that is one thing, is that we can get water everywhere, and we can use energy, or we can use electricity from renewables so that we can break apart hydrogen and get it out. It's just it's more available. That's one thing that's nice about it. The other thing about hydrogen is you can get energy out of it a couple different ways. Most of us think about hydrogen and we think about, the Hindenburg. We all know that hydrogen burns. It burns really well, and it burns fast and over a wide range of flammability. So that's nice. We can use it in some of our existing processes. The other way we can get energy out of hydrogen is in a fuel cell, is where you actually put hydrogen into a fuel cell and it releases its positive energy. The process is kind of technical, but it can directly create electricity. So we can get energy out of hydrogen in a few ways, and it is relatively available to make, though it is kind of expensive. But that is one of the things that makes it unique.
So, in what industries is it possible to start using hydrogen? In fact, it's already in use in some areas.
Yes, that's right. The chemical industry has been using hydrogen for decades. It's used for a lot of processes. Some people may have heard of hydrocracking. That's when you use hydrogen, you introduce it to fossil fuels to remove things like nitrogen and metals. That's one of the ways that we refine oil to make it into usable fuels like diesel, for example. But going forward, we can start using hydrogen more in transportation and for power generation. In the transportation sector, we could use it in highway vehicles, and we could burn it using like a traditional fuel in internal combustion engines, or we can use the hydrogen directly in a fuel cell, which powers a battery essentially for an electric vehicle. So, in fact, this is one of the ways that SWRI is looking into solving the carbon emissions problem from a vehicle perspective. When you look at, so there's already electric vehicles that are available in the market today. So you can go out and buy a Chevy Bolt or something like that. But if you were to use batteries for long hauling trucking, let's say you were to load up a truck here in San Antonio and drive to El Paso, you would have to plug in for about 8 hours when you got there to get enough power to get to your next place. And not to mention, almost your entire cargo bed would be full of batteries, which, as we mentioned, have like really specific chemicals in them that you have to make. So one alternative there is to use hydrogen as another fuel source. So you can have a hydrogen tank that powers a fuel cell, which creates electricity, which goes to a battery powering that truck. So for a much smaller package, you can have all the power that you need to get all the way across Texas. And then when you get to El Paso, fill up your hydrogen tank in a matter of minutes versus 8 hours and continue to move on. So that's a really exciting advancement that we're looking into here.
Yeah, so many exciting things happening in this as you research the uses of hydrogen. So, you just talked about one area at SWRI that's delving into this, the uses of hydrogen, but we have a major collaboration happening at SWRI exploring the transition to hydrogen in several industries. So tell us about how SWRI teams are working together toward this goal.
For those listeners who normally listen to Lisa on this podcast, you've heard of the diverse array of technologies that we research here at Southwest Research Institute. So what we've essentially done is got those power, bringing everyone together, like our powers combined, essentially. Earth Day makes me think of Captain Planet, and I'm dating myself right now, but we basically are bringing together our expertise to solve some of these specific challenges. Let me list out a few of the expertise areas here at Southwest Research Institute where we are looking into the challenges associated with hydrogen. I mentioned earlier, I've been talking a lot about transportation because it's an easy thing to identify with. Within our automotive group here, we are looking at small internal combustion engines for highway use. We're looking at some of the long-haul trucking, like I mentioned, but we're also looking at very large engines, like those that are used on locomotives, 2,500, 3,500 horsepower. So that is one area of hydrogen investigation here. Another one that touches on just about every aspect of the hydrogen economy is our materials science group. Materials science is looking into the interactions of hydrogen with materials, which everything is made of materials. So they get to collaborate with everyone at the Institute. Hydrogen actually does not play nice with most steels and many polymers. It sort of impregnates into them and can create hydrogen embrittlement. So this is an area of ongoing research. Also, within our safety group, we are looking at hydrogen storage on tanks that might be on vehicles or in trailers and other hydrogen storage, and determining if it is really safe to be around that equipment. And then in our mechanical engineering group, we are looking into many things associated with distribution of hydrogen compression, using hydrogen burning in gas turbines, and also looking at things like leak detection of hydrogen. So with all of these areas combined, we are able to help out each other and just really provide a better solution to some of these major hydrogen technical challenges.
All right, it's really become an all hands on deck research collaboration. So shifting gears a little bit, our world currently relies on petroleum products, and we have all this active research going on to look at this transition to hydrogen. But how do you begin a transition to hydrogen when we are right now so entrenched in petroleum products?
Yeah, that is a big challenge. And in fact, the cost to transition over to a new energy source or a new energy storage mode is really high. So I think there's a couple different ways that we are going to start this transition. And I'll break it up into two aspects. It's like, what are we going to do right now? And then what can we do in the near term in terms of research to get the technology up to speed? So what can we do right now? One thing that some natural gas companies are looking at is actually blending hydrogen into existing processes to offset some of the fossil fuels that we use. For example, the natural gas that gets plumbed into your house that you might use to turn on your gas stove, there are local distribution companies that are looking at blending up to 20% hydrogen into that gas stream so that when you turn on your stove, you're actually burning less fossil fuels and releasing less carbon into the atmosphere than you would have otherwise. So that's one way. But we're also looking at blending it into natural gas for internal combustion engines. I mentioned earlier that hydrogen burns really well. So when we start making our engines leaner and leaner and leaner, you get to a point where there's just not enough fuel there to have that spark really create the the engine dynamics that you're looking for. But if you add a little bit of this hydrogen, then you can have your lean burning engine, but you've got that spark to get everything going. So that's one way. And there are companies in Europe, I think, that are looking at blending hydrogen in already for natural gas electricity production. So you'll have up to 20% hydrogen in your natural gas stream, and it'll burn in a gas turbine and make electricity for you. It would be great to just kind of do 100% hydrogen right away. But as I mentioned, hydrogen has some adverse effects with materials, which is something that needs to be overcome, and it also burns much differently. So we can't just do a 100% swap over to hydrogen. We can start blending it in slowly. There's also electric vehicles out there right now that are powered by hydrogen. So the Toyota Mirai is a vehicle that is hydrogen powered, but that's going to be a slow transition. Right now, I think you can only really buy them in California because there aren't hydrogen fueling stations around in the rest of the US. So that's how we're starting slowly. But what really needs to happen is a big transition in our technology. And that is where the US government is stepping in and helping out along with industry. I don't know if you remember the Sunshot Initiative from 2011. It was one of these Department of Energy Earth shots where they were trying to improve the cost or significantly reduce the cost of power generated by solar power. So in 2011, they kicked this off and they had a goal for a decade to drastically reduce the cost of solar power. Well, they did it. In 7 years, they reduced the cost of electricity from solar power by like 80%. And right now, the Department of Energy released a hydrogen shot, which has a similar initiative for hydrogen. They're trying to reduce the cost of making hydrogen down to $1 per kilogram in 1 decade. And this is about a tenfold decrease in depending on how you make it. So there's research going on in funded by the government and also funded by commercial entities that are helping us bridge that technology gap so that we can start using hydrogen sooner.
And as hydrogen gets more affordable, and we will start seeing it. It'll be more common. And I imagine with all the industries that could find it useful, it will be in high demand. So how, you mentioned water earlier, but how do you generate hydrogen on the scale that might be needed in the future?
Hopefully our hydrogen shot, our DOE's hydrogen shot, can help us make this cheaper. But um, there's a couple of ways that hydrogen is made, and one of them actually is from natural gas. We take natural gas and we do a process called steam methane reforming. And you essentially put steam into the natural gas and it drops out some of the carbon and allows you to use the hydrogen. And there's actually a big steam methane reforming plant here in Texas that feeds some of the chemical refineries on our coast. So that is one way that we could make hydrogen, and that would be easily scalable. Unfortunately, it's still using fossil fuels. I don't know if, I guess I haven't mentioned it yet, but there are several colors of hydrogen, and the color represents how the hydrogen is made and how much carbon is actually emitted from that process. So you can make hydrogen from natural gas, like I mentioned, and if you do that hydrogen is called brown or gray hydrogen. If you then follow up that process with carbon capture, that becomes blue hydrogen. There is a process called pyrolysis that we are actually doing some research on here in our chemical engineering division, where you'd use something similar to, you take natural gas, but your output product is not hydrogen or not carbon dioxide. It is actually solid carbon. So it comes out as a carbon feedstock that we can use, and it's easier to handle because it's not going to emit out. If you create hydrogen using electrolysis, and that power, the energy that goes into the electrolysis process comes from renewable energy, then you have green hydrogen. Green hydrogen is the goal. That is the standard where you're not actually creating any carbon emissions while you're creating that. There's also pink hydrogen, which comes from electricity generated by nuclear sources. So there's a lot of methods and there's a lot of technologies out there. Even within electrolysis, there's different technologies there. Some of them can be run at really high temperatures. Some of them require like very specific metals that you run into the same problem that you run into with batteries. But that's actually where the DOE's hydrogen shot is focusing on trying to improve, make clean hydrogen for $1 per kilogram. So we're working hard on this.
You certainly are. So, why do you think that this transition to hydrogen hasn't happened sooner? What challenges does hydrogen present?
Yeah, so there might actually be, there's two questions in there. So why hasn't it happened sooner? One of the things is in the early 2000s, we found just huge reservoirs of natural gas within the US. And this natural gas, once we found out how to access it through hydraulic fracturing, it just really drove down the price of energy everywhere. So that was a huge boon for the United States. But actually, before fracking became a very common practice, hydrogen was really investigated and people were looking at hydrogen. The problem is it's kind of expensive right now because of the technical challenges that we have. So there's this pendulum that we like to talk about that shifts from looking at hydrogen to looking at energy storage in batteries. And right now the pendulum is shifting back to hydrogen. So people have looked into it before, and essentially due to the low cost of electricity that we had, it just wasn't economically viable. But now we, as a nation and really as the world, we've recognized that removing our, reducing our CO2 and just becoming more carbon neutral it's very important for now. It's urgent need, and we need to find some way to get the electricity that we need and live the lifestyle that we want to live in a cleaner way. So that's why essentially it hasn't happened sooner. I think it wasn't economically viable, and there just wasn't, we didn't really understand maybe the long-term impacts, but we do now, and we're going for it. So what challenges does hydrogen use really present? I mentioned a couple of them earlier. Hydrogen, it's a funny molecule. It's very small and it's not very dense. So that means it's hard to contain, and it does weird things to materials. Hydrogen embrittlement is a big problem. Hydrogen embrittlement causes materials to have cracks that instead of leaking, like maybe leaking out the pressurized fluids inside, you have more of like an explosive decompression kind of situation where it'll it'll be fine and then suddenly it will not be fine. So hydrogen, it it's hard on materials. It also burns very easily and clear. I don't know if you knew this, but you can't actually see a hydrogen flame.
You can't
So
see it. You
you
cannot see it.
cannot see it.
Huh.
Yeah. In fact, I've heard a story once about a hydrogen testing facility where someone from SWRI was touring the facility and there were straw brooms everywhere. And he asked, why are there straw brooms? And the person said, oh, we carry those around to know if there's something on fire.
There's one way to find out.
Right, because you can't see it. So hydrogen burns easily and you can't see it. It's hard on materials. Also, because it's not very dense, it's very energy intensive and difficult to compress. So you need hydrogen at high pressures in order for the energy density to make sense. I mean, no one wants to walk around or drive around with a 40-foot tank of hydrogen behind their car. So you want to have something that fits inside your vehicle, which means that it needs to be up to really high pressures, like 10,000 psi. So 10,000 psi of this flammable gas inside your vehicle that you can't see if it catches on fire. There's just a
Nothing
lot of,
scary about that at all.
not at all. And some of the safety tests on these storage vessels are amazing. Our safety facility here can actually take one of those chambers and put it on top of a bonfire. Just like a big bonfire, and let it burn and make sure that it doesn't explode. They can also do like gun penetration, so they will shoot at these vessels to make sure that when they fail in a way that is not catastrophic to the people around them. So some of that work is amazing.
So what do you envision? What do you envision as industries move to hydrogen? How soon could we see a positive impact on the environment?
Well, like I said earlier, there are companies, local distribution companies, that are talking about blending hydrogen into their natural gas lines in the next 5 years. So, or there's actually one, I think SoCal Gas is starting to blend it next year. So it's starting to happen already, and We have a Toyota Mirai, and hopefully once hydrogen is a little bit cheaper to make and easier to make, then it'll be more readily available to do things like use it for electricity production, use it in your vehicle. So I think the transition is going to take a little while. It's not something that's going to happen next week. I think within the decade, we are going to see huge technology advancements. And once the technology is there, then you can start having competition among the people who are making the equipment. It's like once we figured out USB sticks, and then everyone was making a USB stick, and suddenly it costs $3 for a terabyte or something like that. So I think the same kind of thing is going to happen with hydrogen technology, but it's not going to be in the next 5 years. I think we'll make huge technology advancements in the decade, and many places around the world have a target to be carbon neutral by 2050, and I think hydrogen is going to play a huge role in that. In terms of when this is actually going to, when we'll see it in our environment, I am not sure at that point. We have a lot of work to do in terms of correcting our atmosphere and reducing our greenhouse gases. CO2, once it's released into the atmosphere, takes 100 years to break down. Methane breaks down in about 20 years, but methane is actually 50 times more strong of a greenhouse gas than CO2. So we're going to have to find a way to get carbon out of the atmosphere as well as stop producing it. That's kind of like a two-prong approach. That's going to take a while.
So when you think of the possibilities of hydrogen, how do you feel? Are you optimistic?
Yes, I am very optimistic. And part of it is because I have confidence in the researchers here at SWRI. I have confidence in the researchers across the US at coming up with some of those technology advancements that we mentioned. And I think that hydrogen has a real place in our transition away from fossil fuels. I don't think it's going to be the one final solution, but I am optimistic that we are going to come up with some amazing technologies very soon, and it's going to be cheaper and easier to use renewables and make hydrogen in the future than it is right now.
As we recognize Earth Day this month, what can we do in our homes or in our daily lives to cut down on harmful emissions? We're not the scientists or engineers, not all of us are scientists or engineers actively working on this problem. But what are the little things we can do to reduce our CO2 emissions?
Well, I was dating myself earlier with the "We Are Captain Planet" thing. When I was a kid, we all planted trees. And I still believe that planting trees, especially over impenetrable surfaces like blacktop, makes a huge difference. So if you have trees around your house, you can prevent things from heating up and just make the world a little cooler. But there are other things that you can do for electricity generation. You could write to your local utility and let them know how important it is for you that you are purchasing electricity from a company that has our future in mind and that is working towards carbon neutrality. So, and then obviously there's the things that hopefully we do on a daily basis, like carpooling and just driving a little bit less. So I wish I had a magic bullet of something new, but those old tried and true methods of just reducing our carbon production is going to be the best thing. I don't recommend that people stop breathing, though. I think that is one form of CO2 that we need to keep doing.
Yeah, let's not do that. Great tip there.
Yeah.
But to that point, that's really interesting that just the mere fact of us living longer is contributing to carbon emissions. And so that's a great thing. And on the same on the other side of it, as we live longer, we are emitting more carbon. So this is a multifaceted topic. And again, you can find more details and photos in the spring 2022 issue of the Technology Today magazine. Again, that's at technologytoday.swri.org. So I urge our listeners, take a moment and read about the hydrogen technology and development and the research happening at SWRI. Thank you for sharing your important work with us today, Angel.
Thank you so much, Lisa.
And thank you to our listeners for learning along with us today. You can hear all of our Technology Today episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, Twitter, LinkedIn, and YouTube. And now is a great time to become an SWRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Peña. Thanks for listening.